Computer networks are connected by the TCP/IP protocol, which uses IP addresses to communicate. IP address consists of 4 numbers between 0 and 255 separated by periods. It would be really difficult to remember the IP address of everything you want to connect to. When we use the internet, we don't use these addresses to buy books or items, rather we use names to refer to the host we want to connect to. When we browse the internet, we use addresses such as Amazon.com or eBay.com. So how does your computer translate these names to IP addresses? This is where DNS or domain name system comes in and provides this functionality. How DNS works is a topic for our video today. Let's get started. Initially, when the internet was started, all computers used a plain text file named hosts.txt that was used to map hostnames to IP addresses. You can still find this file on computer systems. In the case of Windows, it is located in the System32 directory. Each user downloads a multi-thousand-line file hosts.txt from a single server maintaining a centralized database, making it slow and inefficient. The DNS was created to solve this problem by creating easy-to-remember domain names that map to IP addresses. It was documented in RFC 1034 and 1035 of documentation. The domain name system is a hierarchical and distributed naming system for computers. At the top of the hierarchy is the root domain, under which all other domains reside. Below the root domain are top-level domains, which we call TLD. Below the TLDs are second-level domains that organizations and individuals can register. Each TLD has its own registry to register the individual's domains. Below the second-level domains are the third-level domains. Each domain has its own domain name server called the authoritative name server for that domain. This authoritative name server is responsible for name resolution for a particular domain. Before we review how DNS works, let's consider computing.and-coding.com want to publish their web server and its mail server to the internet. Their web server name is www.computingandcoding.com, and their mail server name is mail.computingandcoding.com. The first thing is needed to create a record of these servers in the DNS zone file. A zone file consists of one or more resource records. The most common type of DNS record is an A record. This is what resolves a domain name to an IP address. To be specific, it resolves to the IPv4 address. A sample A record looks like this. The entry follows the standard format for a records in a zone file. First is the domain name, followed by the IN, which indicates the class of the DNS record, which is typically IN for the internet. Next is the record type, which is an address or a record mapping the domain name to an IPv4 address. The IP address is the value associated with the domain name in the A record. TTL provides additional information about the time to live value for the record. Remember that in actual usage, you should replace the IP address with the correct value for your domain, and the TTL value can be adjusted based on your specific requirements. The next record type is the CNAME record. A CNAME or canonical name record is a type of DNS record used to create an alias or nickname for a domain. It allows one domain name to be mapped or pointed to another domain name rather than directly to an IP address. Let's say Computing and Coding has a website with the main domain computingandcoding.com, and they also want to set up a subdomain for their blog called blog.computingandcoding.com. Instead of assigning a separate IP address to a blog website, they can create a CNAME record that aliases the subdomain to the main domain. The CNAME record entry will look like this. Now, when users visit blog.computingandcoding.com, the DNS resolution process will direct them to the same IP address as computingandcoding.com. The next DNS record is the MX record or mail exchange record. And this record is used for emails. The MX record simply points to the server where emails should be delivered for that particular domain. Let's assume you want to send an email to info@computingandcoding.com. Your mail transfer agent or MTA will query the DNS for the MX record for computingandcoding.com because it is looking for an email server, and then DNS will respond back telling the MTA which server to send the email, which in this case will be mail1.computingandcoding.com. Now let's review how DNS actually works. The client wants to connect to www.computingandcoding.com and enter the URL address into the browser. The first thing that happens is that the user sends a DNS request on UDP port 53 to its DNS server. Normally the client contacts its local DNS server that the administrator has configured on the user's machine. In the case of Windows, it is configured under TCP/IP configuration. In the case of Linux, it is configured in file etc/systemd/resolve.conf file, which has an entry for DNS server. Usually, the user has a DNS entry for their local ISPs in their settings, but it is possible also to use public DNS servers, and there are many of them available. Here is the list of public DNS servers available. When your device makes a DNS query for a domain name, the local DNS server first checks its own database or cache to see if it already has the requested information. If the local DNS server doesn't have the information, it initiates a recursive query, reaching out to other DNS servers higher up in the hierarchy. The first referral is to one of the 13 root servers globally. These root servers are the backbone of the DNS and manage the top-level domains. The root server, though critical, doesn't know the final answer to the query. Its job is to direct the local DNS server to the proper top-level domain server for the specific domain being queried. The TLD server provides the local DNS server with information about the authoritative name servers responsible for the domain requested by the client. TLD knows which server is authoritative for a domain through the information provided by the domain owner during registration, specifying the name servers responsible for handling DNS queries for that domain. Provided with the information from the TLD server, the local DNS server reaches out to the authoritative DNS server for the domain in question. The authoritative DNS server finally supplies the IP address for the requested domain back to the local DNS server. Now receiving the IP address, the local DNS server can provide the client device with the information needed to connect to the desired website or service. And that's how the domain name system works. Through this hierarchical process involving root servers, TLD servers, and authoritative DNS servers, your device can resolve domain names into IP addresses, enabling you to access the vast expanse of the Internet. We hope you found this explanation helpful. Thanks for watching. Please subscribe to the channel for future videos and updates.